Hi students, this is VLSI Design. Today's our topic is shifters presented by Subhashamini Devi. After completion of this shifter session, students will be able to what is bit slicing and what is called booth recording. Just we are having shifter means it's right shift or left shift is based on the request we are having that shifting. If suppose want to move the left shift means just we are following some algorithm and shift bit by bit to the left position of the original data. We are following some algorithm. Just we shift the left position by bit. Suppose if you want to original data to shift to right position means if you are if you following some algorithms and then shift the right position bit and then finally we get that shift bits assembled from original data. How many steps finally follow to get retrieve or retrieve from the original data from the position. This is the left shift or right shift bit slice is followed to shifting position. Here we are having some shifting positions. If suppose this is a normal data, we are following left shift and right shift in this shifting algorithm. After that, we are giving this get and finally we get that position. It is the next position. That's mean this is the just given data. After that, bit position is just a shifting position is occurred. After that, we get that bi minus 1 is the final data of that data. This is nothing but bit slice position. This is the barrel shifter. Just mean we are following n bits is followed, 4 bits are followed here, and then 4 bits is each and every bit followed to shifting the position. This is the data wire and this one is control wire. This dotted is given the control wire. This each and every control wire is connected together to the bit 1 to bit 2, bit 3 like that. We are having the connection each and every units or every line. After that data wire means we are giving the data to each and every connecting wires are access to the each and every line. This is the barrel shifter. This is the diagram for the stick diagram for the shifter. That is mainly here we are following the barrel shifter layout diagram and shifter of the stick. After that we are following the logarithmic shifter. Here in this logarithmic shifter we are using the shifting the each and every bits individually and then finally we are having the assemble in the logarithmic form. After that only we get that output. That's why we are using the logarithmic shifter. Here each and every step we are followed the here each and everything we are having some shift here. After that that shifting is given to finally each and every bit is assembled together and shifting once again we are following the shifting and thing. After that take the output logarithm form of the output is given here. Then only we get that final output from logarithmic shifter. This is the layout diagram, stick diagram of that logarithmic shifter. This formula is normally the general formula for the logarithmic shifter. Then this is the barrel shifter. Barrel shifter means input capacitance is normally like that we are having that form steps followed. Input capacitance is followed the n steps and transistors followed the n square steps. Requires an additional decoder for control signals. Here we are needed the external decoder for the controlling purpose we are using this one. Every data signal pass only one transmission gate. It is one transmission gate is used to pass that each signal. Then we are having the n number of transmission gate is required to pass that signal. After that we are having the logarithmic process, and here each and every data are connecting like that. We are having the layout diagram here. This is already discussed in the previous slides. This is the logarithmic shifter. Here we are having the transistors. How many steps we have followed means n log square n steps followed to the transistor steps, and finally log interstage wires, and especially for cycle shifters were using here. In previous session barrel shifter we are using the each and every transmission gates, we are using each bits. Here interstage wires, especially for cycling shifters, we are using here. This is the logarithmic shifter. Then cyclic shifter application is given here. In this cyclic shifter, finite field arithmetic in normal basis, squaring is done by cycling, shifting, encryption, shift throws operation in residential algorithm, DCT processing unit, address generator. Bidirectional shifting can be implemented as a cyclic shifter with additional masking logic. Then Cordic algorithm is also followed in the cyclic shifting. After that cyclic shifting, mux based design is shown in here. Here we are using the single mux is added here. N number of adding n number bits used means n number of mux is produced to process the cyclic shifter. These connecting each other, we are having the dark line. This and first bit and last bit is connected together. After that, the second and this one is connected. Like that, we are connecting and simplifying the each and every cyclic shifting process. This is timing of this one is also shifting and non-shifting paths are intertwined together. Wire load on the critical path is followed. How many steps followed means n log square log 2 base n is followed here, and then power is when configured to pass through the non-shifting paths have to be switched as well. This is the fan out splitting shifter. Fan out means maximum number of output which one is produced, that is called the fan out of that circuit. Here we are using the n number of shifting is upward, and then n number of gates will produce in the output session. That's why here fan out is maximum, so uses the muxes instead of these muxes. Mux means we are using the one to many, we are using the mux, that's why we are using the muxes, that's why we are the fan out in this session. This is the splitting dial which is capable to access one data, and then timing is here we are using the n is the longest path, and then shortest path we are shifting, and non-shifting paths are at that. Red lines are signal lines and green is the quiet lines. Then red only active line of that signal. Here we are passing the signals each and other. This is the quiet lines. Then after that we are using the dynamic power consumption also. Then gate complexity. This is also followed the 0 n log 2 n. This is a normal implementation. After the duality means here same thing, NAND gate and NOR gate. Duality provides flexible for low level implementation. NAND gates are good for static CMOS, NOR gates are good for dynamic circuits. Then cell permutation is shown here. After completion of this session, we are able to answer this question. Give the difference between Booth's recording and modified Booth's decoding. Thank you, students.